Okay, so hopefully you've tried a couple examples of these on your own, and then I'm going to walk through these ones again if you want to just check them with my work. So again, I'm just going to walk through those same steps that we want to mentally think about as we go. So first, is there a greatest common factor? On this example right here, 12m squared minus 22m minus 20, it looks like there is a greatest common factor, so we're going to divide out the 2. That leaves us with 6m squared minus 11m minus 10. Now again, that 2 is going to come with us. Don't lose that. It's going to continue all the way to the end. Notice that we have a 6m squared at the front that we need to pull apart. So it's either 6m times 1m or it's 2m times 3m. And then we're looking over here at the 10, and we could have 1 times 10 or 2 times 5. Now, one thing that I consider as I'm going through is I look at this and I know that this is a negative 10. So I know that when I find my outside and inside that work together, they need to have a difference of that negative 11m. And a lot of times when you have like a larger number and a larger number, those aren't going to work together when you're finding a difference. So sometimes I ignore the like 6 and the 1 for a little while, or the 1 and the 10, and I try the ones that might get me a closer difference. Now that doesn't always mean that that's going to work, but that's just kind of my thoughts when I start to try some options. So notice here, let's start with the 3m and 2m and the 2 and the 5 just to see if there's a combination there that works. So 3m times 2, that gives me 6m. 2m and 5, that gives me 10m. So those have a difference of 4. That doesn't work. If I do the 2m and the 2, I get 4m. And if I do the 3m and the 5, notice I get 15m. They do have a difference of 11. So we're going to combine the 2, right, with the 5. Okay, just kidding. We already tried that one and it didn't work. Oh, 2m, we wanted it with the 2, right? I should have written this in the blue, and then the 15m. And we want it to be a negative 11, so the 15 is the one that's going to be negative, so I'm going to put the negative back there with the 5. So when I put these in again, I want the 2m to multiply with the 2, so I'm going to put those 2 on the outside, and then the 3m is going to multiply with that negative 5. And then we have our positive and negative, and we should be good there. And we can check our answer again if we'd like to. Notice we get negative 15m, and we get a positive 4m, which results in that negative 11m on the inside. Okay. So again, it's not like I knew that 6m and 1 and 10 wouldn't work, but oftentimes when you're doing a difference and it's a smaller value, we want to go with the smaller values. Okay, let's try some more. Again, if you haven't stopped and tried these, go ahead and do so. We look for a greatest common factor. There's not one on number 1, so I'm just going to list out, this could be x and 3x, and this would be like 1 and 7. I feel like we may have done one like this already. Notice here I have a negative, so I'm going to want a difference of the middle term, so a difference of negative 4x. So then I start to match these. Here I get 3x. Here I get 7x. That's perfect. We want a difference of negative 4, so the bigger value needs to be negative. So I'm going to slide that to the back. And we're going to put these into our parentheses. So we're going to have x and 3x. And again, I want the x to multiply by negative 7 on the outside. So it's got to go over here. And the 3x and the 1 were my insides. So they're going to go here. Okay, we look at the next one. This one does look like it has a greatest common factor of 5, so let's factor out a 5. We get 4y squared minus y minus 5. So again, in the end, that 5 is going to come with us, and it looks to me like we're going to have different signs, right? So we need to find combinations that have a difference of, and it looks like it's negative y or negative 1y if you want to think about it like that. So we list these, right? 4x and 2x and x and 1 and 5. Now, if I look at this, I already know that 4 and 5 are both factors, right, that have a difference of 1. So I can kind of see that that's what's going to work here. I don't want to mix the 4 and the 5. That's going to give me 20. So I'm going to match the 4 with the 1, and I get 4x. and the x and the 5, and I get 5x. Now again, I want it to be a negative 1y, so I make the larger value negative, and that goes back with that 5. So I want the 4x, right, to multiply by the 1, so they get to go on the outside together. And then we have the negative 5 that's going to multiply on the inside with the x. Okay, now if we're solving by factoring, we're doing the same thing. You're just going to state the solutions there at the end. So again, you have to follow those steps that we recalled at the very beginning of this lesson. So we're going to first set it equal to 0, right? Always set equal to 0. So we're going to subtract this 7 over. And then we make sure that we write it in standard form. So we add 3 minus 7 is negative 4. And that is in standard form, so we're ready to go. We look for a greatest common factor. It doesn't look like there's anything that divides out of them. So we start to factor, right? We know that we're going to pull this apart and equal to 0. And the only thing that multiplies to 5b squared would be 5b times 1b. And then as our last number, we could have 1 and 4 or 2 and 2. And notice these need to have a difference because it's a negative of, and then the middle term, right, is like 1b, so they need to have a difference of 1. So this one actually is very similar to the last one. We've got a 4 and a 5 here that we know have a difference of 1. So we know that maybe we should match the 1 with the 4 again and get 4b, and the 5 with the 1 and get 5b. This time that middle term is positive though, so we want the 5b to be positive, and then we'll subtract the 4b, so we make that negative. So this time the 4 is negative. So again, when we put this in here, we've got 5b, and we want it to match with that positive 1, so that the outside would give us a positive 5b. And then on the inside, we would have that negative 4 times b, so that we get the negative 4b. And again, we can check that. Negative 4b, positive 5b, that's what gives us that b value. And then to solve, again, remember we just look at each factor separately, and we say what value would make it 0. So b is equal to negative 1, because negative 1 plus 1 would be 0. And b on this side is equal to 4/5, because 5 times 4/5 would give us 4, and 4 minus 4 would be 0. Again, if you're not good with those fractions, just take that little piece, the 4b minus 4, set it equal to 0, and then solve. So add the 4 to the other side, divide by 5, and that's where that negative 4/5 will come in. All right, last one over here on number 4. So again, we're going to set it equal to 0. Now, I don't love a negative being out front. It's a little bit trickier to factor as a trinomial, so I'm going to add this term over to the other side. So I'm adding 2j squared and leaving 0 on the left side. And then I'm going to write that in standard form. So 2j squared plus 9j plus 9. And notice here that there's no greatest common factor, so we always want to look for one. There's not one here. So we start to factor. We know we're going to end up here, here, and it looks like everything's positive, so we like this one. We want to find factors, right, that are going to add to the 9j. So we start to list those factors. The only thing that gives us 2j squared would be 2j and j. And at the end, it would be either 1 and 9 or 3 and 3. Now again, we just kind of guess and check here as we go. So if we match, maybe I'll start with the bottom one, j and 3. That gives us 3j, and 2j and 3, that gives us 6j. Which there, right, is going to add to give us the 9j that we want. So that works perfectly. We just know that we're going to have 2j, and we want it to multiply by the 3, but both factors on this are 3, so that works out pretty nice. Again, that's factored. Now we want to solve, so we state the solutions. We would have j is equal to negative 3/2, and j is equal to negative 3. Now again, I know I split this up into 3 videos. There's a lot of different videos. Just really important that you guys feel like you have some examples that you can look at and go off of. Again, there are so many different ways to factor where a is greater than 1, some that are a little more algebraic. But this is just backwards foiling, and if we can mentally backwards foil, then we don't have to go through an algebraic process. However, I just would like you to work through the homework, and then if you're really struggling, I will post a couple additional videos next week that you can kind of look through. Also, in your notes, there's a 2.6 for factoring for the regular Math 2 classes. It uses a method called bottoms up. You're welcome to look through those notes and see if that makes sense to you as well, and I can send you a video related to that. Okay, give this a shot. It takes a lot of practice, but the more you do it, the better your brain kind of gets at even matching those pairs. So